Okay, my name is Luanne, and I'm here to speak to you about the Cipher query language, which is the query language for Neo4j, a graph database. So I'd like to know how many of you attended the NoSQL talk and the Programming with Neo4j talk earlier today by Venkat? Okay, great. So I don't have to spend that much time on graphs. So here's what we're going to do today. We're going to spend a little time talking about Neo4j. What is Neo4j? What is Cipher? And then we're going to talk about GraphGists and some examples. So 45 minutes is a bit short to take you through all of Cipher. So what I'm hoping to do is give you enough context and enough examples so that you're able to figure out what Cipher is good for, what you can do with it, what its potential is. And then hopefully you go back and try your own examples. Okay, so what if you have a map? What if you have a map to the Himalayas, okay, where you've got base stations? What if you're a trekker? You want to find routes to reach any one of the peaks. You want to find, can you go there by a vehicle? Can you cycle? Do you need to go by foot? Is the route open in the summer, in the winter? Or what if you come from a learning management domain, okay, where you've got complex entities such as certification, so people who work in large enterprises or corporations, you usually have a lot of learning to take depending on your position. You've got various ways to acquire certifications by taking various courses plus work experience. You need to recertify yourself. There are compliances involved. You can see that there's a lot of connected data. There's also data about what certifications you need to be promoted to a specific position. It plays a large role in talent management. A position is vacant. Who am I going to find to fill it internally? How do I know this person is qualified for the job apart from whatever data we collected about him 10 years ago? What if you come from healthcare? You've got symptoms, you've got allergies, you've got drug classes, you've got doctors. You need to figure out which kind of doctor can prescribe what kind of medicine. Or what if, like me, you come from Bombay and you have to put up with trains every day? What are the routes from one station to another? How do you get cross lines without getting squashed, getting off at the end station alive? Okay, that's Bombay Railway map for you. So all you need for all the above examples, which is according to the Beatles. How many of you are Beatles fans? How many of you know anything of the Beatles? Okay, what's the answer? Perfect. So all you need is love according to the Beatles, okay? But that's not why you're here today. So I'm going to step back a moment. And what you really need is a graph, okay? A graph is the perfect solution to model your complex data, relationships between entities, okay, and get interesting information out of the relations, not so much out of the data, but out of the relations. So you might argue that, oops, I'm sorry. So you might argue that a relational database also has relations, okay? But what you're missing in a relational database is the meaning in those relations. What is interesting in those relations? What data can you infer out of the relations? What extra intelligence can you pull out of entities or nodes which are connected to each other because of these relations? So Neo4j is a graph database. Specifically, it's a labeled property graph. So you have nodes, okay, so edges and vertices, the mathematical concept. In a graph database, same thing, but we typically refer to them as nodes and relationships. So you have nodes with properties and labels. Both are optional. So a property is a key value pair, okay, which allows you to describe your node better. You need not have properties, but you usually do have at least one property. You have labels on nodes. Labels help you to identify your node and tell you what type of node it is, generally, okay? So you can segregate your graph by type. You can look at a node and say, what are you? And, I'm an animal and not an animal and a person. I am an animal and okay, that's a bad example. I'm a man and a woman, to rob Venkat's example. Okay, and that's a valid case in India now. So So you've got nodes, you've got directed and named relations with properties. A relationship in Neo4j must be named. It must have a direction. So you must specify whether it's incoming or outgoing. But it doesn't matter when you're traversing the graph. So there's a distinction there. If you want, you can traverse by looking for relations in a specific direction, but you don't need to. So many times we are asked the question, how do I model bidirectional relationships? Okay, because I'm right here, we are saying that it has to be directed. You can't have a relation in Neo4j that's both incoming and outgoing. Okay, so you have two choices. One is you model it any which way you want, and when you're querying it, you ignore the direction, or you model it with two relations. So example in, let's say a company social network, right? I know you. Okay, so because we're in a company, you know me, that's fairly straightforward. So it doesn't matter whether I know you or you know me. The fact is that we know each other. Consider the Facebook model, right? I send you a friend request. You don't know who I am or you hate me, one of the two. Now here your direction is important because by saying, who are my friends, the guys who've not accepted me yet are really not my friends. So now you have a choice of either, putting on a property saying that, okay, this friend relation is valid because the other party has accepted you, or you put a bidirectional relation so you know that they're confirmed friends if you've got two relations. So how you model is up to you, but I hope that answers the question of how do you do bidirectional relationships. Neo4j is a fully ACID compliant database. Okay, so the same as you would expect from your ACID relational databases hold true with Neo4j. It is schema free. Okay, it's not truly schema-less. There's a fine line between the two. So Neo4j does not impose any kind of schema on your data. Okay, you're free to model it how you want. You can have two different nodes with the same label and different properties on them, perfectly valid. They don't have to have certain types of relations between them. You can add or remove relations as you go along. You can have any combination and permutation of nodes. So there's no such thing as a schema-less database because even if you don't model it, it has some structure in your head at least. Otherwise, that data is completely meaningless. So you do know that nodes are related to each other. You do know that what are the types of nodes participating in relationships. A very common question we get from DBAs is, if there's no schema, how do you manage it? So first, are there any DBAs? That's my favorite question. Depending how big you are, then I'll proceed or not. No DBAs, excellent. Okay, so you do have a schema in your application. It's not imposed by the graph. Okay, you do know that if you and I are friends, we are people and we have a friend relation. It's completely meaningless to say that we have two nodes and they're a relation and nobody knows what it means. Okay, so from that point of view, there is a schema, there is a structure to the data rather. Okay, but there is no such thing as a foreign key. There is no such thing as a constraint. There is no such thing to say that these two nodes must have this relation, else it's not valid. Okay, that is completely up to you. And that makes it easy to model your data incrementally when you don't know everything upfront. Okay, then it's very easy to kind of upgrade your graph model as opposed to an RDBMS. If you don't know everything upfront, you're in considerable hell, especially if you're already in production. Then you go into upgrade script hell and all kinds of customer hell. So that's about the graph as such. It's scalable. It can currently hold 32 billion nodes, 32 billion relationships, and 32 billion properties, and that limit is scheduled to be dropped sometime this year. It can do more than 200 million traversals per second, and it's suitable for highly connected and complex data. So again, the use case for a graph is not everything. If you try to put anything into a graph, you will suffer. What you're looking for is data that is connected, highly connected, and you're looking for data that you want to extract out meaning or intelligence from those connections and traverse through those connections. Okay. So there used to be graph databases some 20 odd years ago. They were called network databases. They were not wildly popular. But the reason for that is that 20 years ago you didn't have this much data. You didn't have this much meaning in the data. Sure, you had a lot of enterprise data. You had fat payroll systems, you had accounting systems, and the RDBMS is perfect for it. I mean, it still is today. This is not an RDBMS bashing session. It still is. And if you try to put your payroll into Neo4j, you will cry, believe me. So don't do that. But what you have today, because of the internet, is you've got a lot of data, a lot of social data primarily, okay, where you are now looking at things like recommendation engines. You're looking at routing problems. You're looking at inferring information because things are connected together. Okay, you're looking at predicting how a person or an object will behave because of past behavior. So these are cases where you want to consider or look at a graph database. Yep. So Neo4j basically stores it in a set of actually 3 files on the file system. They're basically stored, well, an extreme simplification is they are stored as linked lists, okay, of relationships and nodes. If you're more interested in the details of how Neo4j stores it, there's a book called Graph Databases published by O'Reilly, and the e-copy is free. So it has all the information you would want to know about that. Okay, so an example. Okay, this is, of course, the standard Neo4j example. You've got a set of nodes, okay, 5 nodes. You've got relations between them, and you have got properties on the node. So you can see the name is a property on the node. You also have properties on relations, as I said earlier. So you've got like Neo knows Morpheus since 1999. Since is the key, and 1999 is the value. So all properties are key value pairs. The values are primitives plus string and arrays of primitive plus string. Okay, you can't like nest an object as a property. You've got to pull that out. Okay, and additionally, you have labels. So as I said earlier, a label serves to be a type. It serves to be a tag. You can see that there are 2 labels in this. One is crew and one is matrix, and you can also see that a node can have more than 1 label at a time. You can put as many labels on it as you like. Okay, so visually it helps. You can immediately tell, you know, who are the crewmen and women, and who are the guys belonging to the matrix, okay, and how they're related. And really, when you're modeling Neo4j, and you're when someone is describing to you the domain, what you draw on the whiteboard is exactly how you model it in 95% of the cases. The 5% is when you optimize it, you know, for performance reasons. So then, what is Cipher? Cipher is the graph query language for Neo4j. Okay, it is really a query language. You have languages in every driver. You have drivers in every language for Neo4j, but Cipher is not language specific. Okay, it's based on English and icons, and what it focuses on is what to retrieve from the graph and not how to retrieve it. So you don't really have to specify, go from node A to node B via this relation, and then, you know, do a breadth first and do a depth first and all those things. You don't have to specify that. You basically tell it, this is the pattern that I'm looking for, okay, and Cipher will go off and match that pattern. And what you're focused on is your domain rather than the internals of database access. Okay, you're completely shielded from that. And it's a query language that's suitable for developers as well as ops professionals. Okay, so as opposed to SQL, which your manager will never ever want to read, okay, Cipher is very understandable. Anyone who looks at it is able to tell you, okay, this is what I'm looking for in the graph. Okay, so the aim is to actually put some control into the hands of non-developers. So BI people, project managers, you know, all the guys that don't use SQL. Okay, so have a look at that picture. Neo loves Trinity, 2 nodes, okay, with a relation. How do you read that in English? Neo loves Trinity. Okay, so that's English. And that is Cipher. Okay, so you've got Neo loves Trinity. So in the simple brackets, you've got your node, okay? In the square brackets is your relationship, and of course the last thing is your node. So even by looking at it, you can tell that there is an outgoing relation from Neo to Trinity, okay? Relation type is loves. Another example, that's your picture, that's your English, and that's the Cipher. Okay, so It's extremely readable. It's extremely understandable by non-developers. Let's take another example. So here I have modeled a very, very, very simplistic use case. The orange guys, the orange nodes are users, and the purple ones are artists. So you have friends. Okay, so Luanne is a friend has F2 as a friend and F1 as a friend, and all these people listen to music. Okay, and there's a pre-computed value of similarity. So how similar are you to another person? Okay, so that's a pre-computed value, and that's stored as a property on the relation. And if you look, so what this Cipher attempts to do is suggest to me what other artist should I listen to. Okay, so what we're going to do is we are going to first describe the pattern. So in the match clause, the match tells you look for this pattern. So you're saying start at Luanne, okay, because your recommendations for me. Find all her friends, okay, find what artists her friends listen to, okay, and then you go to the where clause, which is exactly like SQL, okay, filter out. So first remove all the artists that I already listened to. I mean, I don't want to be recommended those again. And recommend to me artists only from people that are as similar to me as possible. So we've put a random number of 0.7 over there. So if you and I are completely different, I mean, I really don't want to listen to your music, or I might not like it. But if I have similar tastes, then okay, I might like your music. And then we return the artist. So how does it work? So you start at Luanne, okay, and you find the friends. So it goes to F2 and F1 it's not really that order, but yeah, it finds the friends. Okay, and then you move ahead to the next part of the pattern. Okay, and you find out what artists do the friends listen to. Okay, so you'll see that there are 3 artists. So this one is here because F1 also listens to the Beatles. Okay, so that's what your pattern has matched so far, right? Now you start filtering out your data. I don't want the Beatles because I already listened to them, right? Not interested. I don't want friends who have a similarity of less than 0.7. Okay, so F2 is out of the picture. Because F2 is out of the picture, that entire path is out of the picture. So all the way F2 down to Pink Floyd is gone. You filtered that out. Okay, so that actually leaves you just with Aerosmith. Okay, so that's just an example of how you transform your pattern matching into a Cipher query. So here's an example structure just to give you an idea of what forms a query. It doesn't really do much. Okay, in fact, it's pretty nonsensical, but I just want to show you what's in it. Okay, so your query can be as simple or as complicated as this. So the first part, which you will always have, is a match clause. So the match clause allows you to specify patterns that Cipher will search for. Okay, so match is your most important part. You're all looking for a pattern. You'll tell Cipher that your pattern is here, and that's in the match clause. Okay, so those are examples of match clause. You can have as many or as few of them as you want in your query. So you can see that we're just describing 2 patterns. A user listens to an artist plays in a city. Okay, that's match. Then you have the where clause, as I said before, similar to SQL, filters the results and adds constraints to patterns that are described in the match. So this is very obvious. Okay, you're filtering on properties in this case. Returns results. Order by limit to all SQL people, standard. Okay, sort, reduce the, return a subset. Okay, and then you've got width. So width basically allows you to manipulate your result sequence by changing either the shape of the data returned, okay, or by limiting the data returned. So you might want to actually constrain your data and then pass it on to the next part of the query. So it's typically used to chain subqueries, and you will find that width is extremely, extremely useful to write complex queries and more importantly to tackle a lot of performance issues. Okay, so you can see the width there. So basically what you're doing is you've matched a pattern, okay, and now you're passing on those results to the next part of your query. So it's kind of like chaining 2 subqueries together. Okay, so now we're going to move on to GraphGists. Okay, so first of all, what's a gist? So for people who are on GitHub, you'll find that this already exists as a simple way to share snippets of code, data. It's versioned. Okay, you can fork it. It's nicely rendered, presented. That's a gist. Okay, so then why are we talking about a GraphGist? So how do you share your model? So let's say that you've come up with this awesome graph model. How do you share it? Okay, do you get your entire team into the same room with that whiteboard and hope that nobody erases it overnight? Okay, do you take a picture and do you mail it? So fine, okay, maybe you took a picture and you mailed it. After that, what happens? How do you demonstrate your queries, right? It's one thing to look at a query and it's one thing to execute the query and see the results. If you need to execute the query, you need a live database. Okay, so that's another problem. Do you like zip your database and mail it across to all your team? And then the worst part is when you incrementally change your model. So you've added a new relation. What do? Do you like redraw it on the whiteboard and send pictures and a new database and tell everyone, okay, forget the old mail and look at the new one? This is a really common problem, and a GraphGist will solve that problem for you. So it's basically just an ASCII doc file. That's all it is. I'll show you a sample of what it looks like. Typically, and of course, you can put in anything you like, but typically what you put into it is your domain model, descriptive text and pictures, example queries against the model. It basically runs an in-memory Neo4j instance for you. So you can write out your queries and they will execute for you within the same GraphGist. Okay? And it also comes bundled with the Neo4j console, if you want to try out queries against that model. So this is the best way to share your data, to communicate your model, to do some R&D on your model, to play around with queries, change your model. This is really the way to do it. So we're going to actually go through a couple of these. Neo4j recently ran, or rather they ran 2 contests for people to model their domains as GraphGists. And the first time they had some 18 odd entries, and the second time they had like 67 entries. So if you go to neo4j.org, you will find pretty much a huge variety of GraphGists from all kinds of domains possible. Earlier it was kind of tough to, if you came from some odd domain and you didn't know how do I use Neo4j, then you had to struggle or ask people questions. Now a lot of people have done the hard work for you, and there's like a kind of a sample graph model with use cases and queries. So it's a very good starting point. If you want to start modeling with Neo4j. Okay, so I am going to switch to my browser. So those are the 4 we're going to go through today. Yep. What do you mean? Okay, so you don't need to run it in embedded. Neo4j already comes in server mode. So you run a Neo4j server and you have n number of clients connect to it. Is that what you meant by client server? Yeah, so it runs in its own JVM on a different server, or on, basically you just needed your own JVM for it. So you can host Neo4j as a server, okay, independently, and then connect all your applications to it. Okay? So embedded is one way of looking at it. Embedded only runs for people in the JVM, but you have various non-JVM drivers as well. So for them, the only choice is to use a Neo4j server. Okay, so let me switch out here. So is that too large? I'm afraid you may not be able to see the query, so I'm going to leave it this large, but tell me if it's not readable. So the first was, of course, the trekking graph. Okay, let me switch first. So what does this look like? Okay, this is the ASCII doc file. Let me see if I can increase that font. Okay, so there's nothing in it. I mean, it's text. That's it. Okay, there's a lot of an explanation. There are links to pictures, and then you've got your Cipher directly in it. Okay, so you've got your Cipher, all your queries, and and that's it. That's the result of this is what you see in the browser. So it's really easy to get started with a GraphGist. You don't need a programming language. You don't need an ID. You don't need anything. You can just start with a text file. Okay, I need to reduce this because Yeah, maybe I can move the project. Can I move the projector maybe a little to the of a series of Cypher statements? So Cypher can be used both to query the graph as well as to create your data. So you've got create statements, okay, where you can see that the string after the colon is the label. So in this particular graph, you've got towns. Let's see what else there are. There are peaks, okay. You've got properties on the graph, which look, like a standard JSON formats, okay. And then you've got relationships. So you've got, for example, a relation between two places, okay, and the relation is called trek, which means that you need to trek there. Or there's a road that exists. What's the distance between them? These are properties on your relation, okay. And then you've got more properties on the relation, which indicate whether it's open in the summer or the winter. Okay, so this particular model, this particular person has chosen to model the connection between two places, okay, as the route which has all the information sitting on it. Okay, so you can't say open in summer on a town or on a peak. Makes no sense. But is the route from the town to the peak open in the summer? So that's why you have these properties on the relationship. Okay, so you've got a whole bunch of create statements. Okay, and that's a sample of what the model looks like. Okay, so here let's start with some simple use cases. Find me all the peaks where I can go on a cycle expedition. Okay, now two-wheeler was the name of a relation. So you're looking at starting at a town. Okay, so it doesn't really matter how you write your Cipher, whether you write it, town two-wheeler peak or peak two-wheeler town. In this case, he hasn't specified any direction on it, but you can invert them for readability. So basically, he's starting from a town, and he wants to know from any town that's available to me in my map, which are the peaks that I can reach by a two-wheeler. Okay, so you can see the two-wheeler, and what the star means after that is n-level hops. Okay, so by default, it's 1. If you just say two-wheeler without the star, it's not 0, it's not more than 1, it's 1. So it means that if this is a town, you're going to find a peak that's connected by 1 hop, which is good, I suppose, if you're lazy, but not really practical. So what this does is it basically traverses to n levels of depth, okay, to finally reach that peak. Okay, and there's just one peak that's apparently available on a cycle expedition. Okay, find me all base towns for the cycle routes. Okay, so the same query as before. Okay, what you're looking at is now you fixed your peak. You want to find what are all the base towns that I can start from if I want to go on a cycle expedition, and that's basically what this query does. Full routes. Okay, so you have a peak, you have a town. Now you're not you're basically saying that. Fine, I know I can reach there by a two-wheeler, but what are the different routes that I can take? Okay, so what this gives you is an entire route, okay, which is why a graph database and Neo4j in particular is useful for all your kinds of routing problems. Okay, this is very, very trivial query to execute. You might die if you were in a RDBMS. So this is a very good use case for a graph. So you can see that. You start here, and then you have a two-wheeler ride here, and then another one, and finally you reach your peak. Okay. Are they open in the summer? Same query. All you've done is you've added a condition. So you could have put a where summer equal to true, or you can write it in shorthand, which is basically use a JSON kind of notation. So it's the same as a where. I mean, there's no performance impact or anything, but it's just a shorthand way. Okay. And similarly, you can answer a whole bunch of queries like, I don't mind trekking just the last part. Okay, but I want to get as close to the peak as possible by car, and then I'll walk the last part. So you can see this is a slightly longer form of the Cipher. So you're starting at the peak, you're trekking, okay, from a village, and the village to the town, you definitely want a road. You're not going to walk all the way. Okay, so these are actually very, very simple Cipher queries, very simple queries to ask a graph. Let's move on to the next one. Organization learning. So this is one of the examples we talk about. So I worked in a company that that had learning management, and they tried to hook up talent management, performance management, people management, all kinds of things, and they succeeded, I suppose, in an RDBMS, but it was a lot of hell. They took like millions of tables, and first they normalized it so much, and then they denormalized it so much, and then they half normalized it again, and then they tried MongoDB, and then they went back to the RDBMS, and I currently don't know where they are. But Neo4j would have been a really, really simple solution. So this is an extremely simplified picture of what a certification looks like. Okay, so a certification basically has a lot of paths that you can take to acquire that certification. Okay, so you can see the path on the left, path 1. You've got to do 3 things to acquire that certification. Without doing all 3, you don't get it. Okay, so you've got like learning item 1, 2, and 3. Now, learning item means nothing. I mean, how do you accomplish that learning item? So you can see that these 2, or rather all these 3, are fulfilled by a course. So you must take a course. If you pass the course, and sometimes there are criteria on the course, you must pass with 80% or more, etc. Then you fulfill that learning item. Only then are you eligible to move to the next one. You might have learning items which are fulfilled by other things. In this case, I've taken an example of work experience. You must have work experience of 20 hours, 30 hours, 40 hours, okay, etc. So there are various ways to acquire a certification. This is extremely important in companies which have compliances based on learning. And it's not always simple to navigate, because you've seen like a really tiny part of the certification, but it's much more complex. And when you try and throw in other entities, okay, so you throw in people that already hold certifications, you throw in people that hold positions in the organization, you start connecting positions and the certifications that a person must have to occupy this position, okay, and then what is impossible to show here, that, positions belong to jobs, they have locations, they have minimum criteria, they have skill sets, they have all kinds of things, right? So what should be a very simple question, hey, someone has left, can I fill this position internally, is actually very hard to do, okay? It is extremely hard. We've seen a process that, they run every night, just to figure out how do I find these people that are the best fit, and then, they get an Excel report, and then some poor chap in HR sits and reads through Excel, and, it's quite horrible. So what this does is, this helps you to easily, so this is what the graph looks like. So this is what I meant by there's an in-memory Neo4j database. My Cipher is executed, and this is really what your graph looks like, so you can play around with it and stuff. Okay, it's not so interesting right now, but you can. So a very simple question to answer. What are the prerequisites for a course? Okay, especially when you have n levels of depth. Here we're just saying what are the first level prerequisites. Okay, a very easy question. What learning paths does a certification have? Okay, so you start at a certification, which in this case is certification 1. And we go through n levels of next learning. So if you recall, certification path is made up of a connected series of learning items with a next learning relation, and there's a property on that relation which is called a path. So this actually qualifies, what is the name of this path and what is the name of that path. You might have the same learning item that participates in more than 2 paths. That's entirely possible. Okay, so now your query is much easier to solve and to even describe. To write SQL for this is quite a pain. So you've got a certification that has n levels of next learning, and those learning items are fulfilled by something. Okay, and of course the with head basically just makes sure that this portion just makes sure that you're on the same path. Because your learning item was shared between 2 paths, you don't want it to kind of cross over and go into the next into the next path. So this part makes sure that, okay, if I started on this path, these are all the learning items. Extremely trivial for Neo4j to solve. And you can see that these are all the paths that are available to you. Questions such as, to be certified in this, what path can I take which will contain only web-based courses? So maybe I don't want to do work experience, maybe I don't have the time. I just want to sit at home, okay, and take web-based courses. Extremely easy query to ask Neo4j. Again, all you're doing is finding paths, okay, and you're basically restricting the fulfill by, and you're saying that I want these to be only web courses. So in this particular example, I chose to model the fact that it was a web-based course as a label. Okay, you could have stored it as a property. In this case, it was easier to store it as a label because the kinds of queries that I wanted to ask of the graph lent itself better to labels. Okay, so basically you're looking for all the web-based courses. What certification does a person need to move up to position 2? So this is an example of 2 parts of a query. So what certifications does position 2 require, first of all? Okay, so get all those. Yeah, find my person. Okay, so person 1 is the guy we're interested in. Figure out which of those certifications person 1 does not hold. Okay, and those are your missing certifications. Which people don't have required certification. So HR always love to say that, you know, we have a minimum required certification for a position, but they fill them anyway. For people in compliance, okay, apparently this is vital information. Find me all the people who are sitting in positions but aren't really, you know, don't have the certifications net. Okay, so what you're doing is you are looking for people that hold positions which require certain certifications, and the person does not have that certification. So really, really easy, and I've written these queries in SQL in the previous company, and they were really bad. What are potential positions for a person? Okay, so here I am, and I aspire to, you know, be promoted. So what are, based on my current knowledge, okay, I'm also very lazy, I'm not going to learn anything more. Okay, based on what I know currently, what are the positions I can fill? Again, a very easy question to answer. Okay, so here's a person. These are the certifications he has. Okay, so these are my held certifications, right? These are all the positions, and these are the certifications they require. So these are the required certifications. And then what I want to do is figure out which of the where am I? Yep. So basically find out, are all my held certifications contained in the required certifications? If so, then I'm a candidate for the position. Okay, so even descriptively, this kind of makes sense. No matter how your data is organized in a graph, this is very, very easy to kind of go through. Okay, so moving on to doctors. Okay, so you've got symptoms, allergies, pathologies, drug classes, doctors. So when you want to answer questions such as, okay, so this guy has actually written them out very neatly as use cases. So as an application user, when I start typing my symptoms, find me matching symptoms. Okay, so sorry, that's autocomplete. Okay, I have symptoms. What are the drugs that can be prescribed for those symptoms? Okay, so here's an example of the query. It looks long, but it's actually it's very simple if you break it up. So you're looking at a pathology, okay, which manifests various symptoms. Okay, and we know the guy has these symptoms. Okay, so this first identifies what are the pathologies. Then you're looking at what are the drug classes that cure this. Okay, and you want to make sure that this particular class of drugs can cure these symptoms in a person of whatever age. In this case is 35. So now you've got drug classes. And then finally you want to know which are the drugs in that drug class, and you want to exclude the drugs, okay, which may cause an allergy that the person has. Okay, so when you talk about it, it seems like a very long query to write, but you know, if you segregate it into match this, then match that, then exclude something else, it's extremely easy. Okay, and these are the examples of what it finds you. Okay, similarly, basically I have symptoms, find me doctors that can prescribe these drugs, okay, and how far does the doctor live for me, or maybe I don't require a doctor prescription. So this example has been created by adding a lat long onto the doctor and onto the patient, okay, and they've used a Habersign formula here. You need not do this. Neo4j comes with a Neo4j spatial module, which will at least get rid of this part of your query. Okay, so you can find doctors, you know, within a few kilometers. Okay, the last one, which is my favorite. Okay, so this is really what it looks like. People from Bombay. It is not an exaggeration. I mean, I really have hung out like that. Well, not as bad as the guys on top, but yeah. So you're looking at railway lines. Okay, at least Bombay has 3 major railway lines. There are a couple of minor ones. Okay, but we won't talk about them. So you're looking at trains that run on railway lines, which kind of partition the city into, you know, the western, the central, and the tiny harbor line. And sometimes when you've got a crossover, from the western to central, you've got to change lines, you've got to change trains. On top of that, you have fast trains, slow trains, all those kinds of things. Okay, so it's a routing problem. I mean, that's all it is. These are basic shortest path. But what happens when you have a path like this? Okay, find me the route from Elphinstone to Andheri. Okay, now, it's 4 stations, right? But it's not that simple. Basically, what you're doing is this is a slow train, okay, from here to here. And then you have a fast train, because that's the shortest part, because in between this and this, there are 3 stations. And in between Bandra and Andheri, there are another 3. So it's really giving you the shortest part, which is what you asked for in the first place. But if you were to try this, okay, so all my queries here come with a disclaimer. If you try it, I'm not paying your medical bills. If you try switching stations like this, you are literally in scenarios like this. So if you'd like to try my routing, use my query, which basically says, find me a route where I don't have to switch lines and I don't have to switch trains. So first of all, be thankful that you got into a train in the first place. And then when you're in that train, please stay in that train till you get off. Okay, so what this query does is the same. The first part is the same. Elphinstone to Andheri, okay, match, find me all the paths. And then what you do is you pick off the head of the relation. So R is your relation. So since you're in that train, what is your first path? So you pick that, and I say, okay, I'm on this line, and I'm in this kind of train. And then you make sure that every single relation in that path belongs to the same line and belongs to the same type of train. So is it fast or slow? So that's what all this does. It looks a little weird, but basically all it says is every relation must have the same train type as the starting train type. Every relation must have the same line as a railway line. Okay? And what you get is not 4 hops away. It's considerably longer because it's a slow train. But if you wish to live, you will sit in it. Okay? So that's basically what Neo4j can do and what Cipher can do. Let me switch back for a minute. Okay, so I have 2 minutes left to go. So a couple of resources before I wind up. So Neo4j is at neo4j.org. You can very easily create your own GraphGists. What I would suggest is you find a domain that you are closest to, fork that, okay, modify it, try it out. You don't need to install Neo4j at all. Okay, you can work purely in your GraphGist. There is also an online training course for Neo4j, which is free. Those are your best resources to actually get started on Neo4j. And that is all I have time for. Are there any questions if I have a minute? Sorry. I'm sorry? Yeah. Yeah, you can do that through Cipher as well. Delete node, change. You can't update a relation. You can update properties on a relation. But if you want to change a relation, you have to drop it and create a new relation. But all those are available in Cipher. Not that I know of currently. So most of the tools for Neo4j are developed by the community. I have not read anything about this so far. I could be wrong. But your best place to ask would be on the Neo4j mailing list. So you have virtually the entire Neo4j community. So if someone has done it before, they will tell you they've done it. Yeah, a label actually provides behind the scenes creates an index for you. Yeah, so, right. So what is now called the legacy indexing of Neo4j is basically built on a Lucene index. So even labels are backed by a Lucene index. So you can create an index on properties and types of nodes, etc. Even full text indexes. All those can be done.
Are there any chances that we would be able to visualize the labels soon on the record?
You can already. You can already. They actually show up as colored nodes.
But I know the text that's coming because I read somewhere that it would come in the next release. That is in Neo4j 2.0.
Okay. Okay, so currently the the 2.0 web admin shows you the node in a color, and if you click on the Neo4j symbol on the left hand side, it will basically tell you the various kinds of nodes. If you click on a node, irrespective of the color, it pops up a little black div over it, which tells you what is the type of the node, or rather the label of the node and all the properties. So that's all that there is today. Okay, thank you everyone.